Jengo Blocks is an educational sculptural puzzle that is meant to raise awareness and teach citizens about specific factors pertaining to flooding in Kisumu, Kenya. Each block represents an abstract of the specific issues and shows the dynamic relationship that they share with each other. Users can piece together the individual boxes to complete the puzzle on the back. The images used in the puzzle reveal the nature of the factors inside the blocks and what they represent. The front shows the non-intervention factors on the left side, the intervention factors on the right side, and the transition blocks in the middle. The dynamic relationship between the factors can also be shown by matching the color tape on the front. Users can match the colors with adjacent sides. However, there are multiple ways to match them up. We deployed our design to a grade 11 Earth Science class at David Thompson Secondary. We quickly briefed them on our goals, motivations, and give them a cultural probe activity as a form of reflection in action to gain insight about their raw perception of our design and their understanding of flooding. On the last day, we collected the cultural probes and distributed a quiz using reflection on action to find out how much they were able to quickly reflect on the issues. To be as unintrusive as possible, we asked the teacher to document and make observations while the students were interacting with the blocks.
I thought the design was very simple and well constructed, and I thought that it was a good idea to have something very low-tech considering the target audience. Yes, I did not expect that they would be so enthusiastic about the project. These students are fairly unmotivated, and in the 2 months that I've known them, have not shown that kind of engagement with any of the other activities they've done. I think part of the reason was the simplicity of the design and the very minimal instructions that they were given. They were not constrained by having to think too much about it. They just intuitively interacted with the design. Firstly, they were very hands-on with it. They started manipulating the blocks in different ways, and then the second part of it was that they were in a group, and so because they had the support of each other, they were freer to interact with it. My student helper is an AP student, and he is in grade 12, and so I thought that they would make a great differential between how these students respond and somebody who has a little bit more experience and exposure to scientific concepts. When I first told her about the project and I showed her the prototype, her exact words were that it gave her goosebumps. And when she attended the class, she was very impressed by both the presentation and the outside the box thinking of these earth science students. Yes, I think that they were able to see the major issues that were represented in the blocks, and they could, from that, think about possible solutions. I think it was successful because it was a very simple, clear idea that that was something very relatable to these students.